And the application parts, application 1, applications in the 6 units the same as applications. Application of Bernoulli and binomial distribution, applications of Poisson distribution, application of negative binomial distribution. Application 2, problems of hypergeometric distribution, problems on uniform distribution, and miscellaneous problems on discrete distribution. So we can learn this one. So we can learn these topics today, these 11, 12 topics. We can learn Bernoulli and binomial distribution today. So we can see here. So in the discrete distribution in this block, so Bernoulli and binomial, the characteristics of properties and considered, and the characteristics and the properties of the Poisson distributions in unit 2, and the while unit 3 is concerned with the discrete uniform distribution properties and the characteristics is there. So in this Bernoulli and binomial distribution is Bernoulli trials, definition of Bernoulli distribution, properties of Bernoulli distribution, what is mean and what is variance, coefficient of skewness, moment generating function, characteristics function, and binomial distribution, definition of binomial distribution, deviation of binomial distribution, and again properties of binomial distribution, coefficient of skewness, coefficient of excess of kurtosis, moment generating function, characteristic function, probability generating function, additive properties of binomial distribution, cumulative generating function, mode of binomial distribution, recurrence relation for binomial probabilities, cumulative distributive function, recurrence relation for central moment, and the recurrence relation for cumulative. So all these things we can learn in this first unit, Bernoulli and binomial distributions we can learn here. And the objectives we have to take in here. So identify the situations where Bernoulli distribution and binomial distribution can be used. Define the probability mass function and the above distribution. Identify the characteristic feature of these distributions. Study the various statistical measures like mean, variance, coefficient, skewness, and kurtosis for the above distributions we have to learn in this day. So what is the Bernoulli distribution? So what is it? The distribution was named James Bernoulli. So this Bernoulli distribution was proposed and named as in this book the James Bernoulli 1654 to 1705 in this book the Arts of Conjectancy. And Bernoulli trial. So when the random experiment results in two and only two mutually exclusive and exhaustive outcomes we are taking here, the probability result remains the same each trial when the expenditure repeated independently, such as experiment is called. The Bernoulli trial, what is the Bernoulli trial we are taking here? The random experiment also we are taking here to mutually exclusive and exhaustive outcomes. The probability of the result remains the same. The experiments repeated independently and such as experiment is called as Bernoulli trial. So first of all, so we can take the 1, 2, 3 conditions we can take here. When a fair coin, so suppose a coin is tossed here. So when a coin is tossed, there are two mutually exclusive and exhaustive outcomes. Exhaustive outcomes to these two exhaustive outcomes is there. So in the two exhaustive outcomes is there a head and a tail. So suppose one coin should be coin toss here, one head and one tail, minute bit generally it getting a head is considered as a success and getting a trail is considered as failure. So success is calling as head and the failure is calling as tail as calling as failure here. So since the coin is the probability, suppose coin is you can toss it is a probability is failure and success it is 1/2. So P is equal to 1/2 and Q is equal to 1/2. So the coin not a fair coin and then the values P and Q may be equal 1/2. So however the values P, Q are the same, but P is equal to 0, P plus Q is equal to 1. So P is equal to 1 by 20, Q is equal to 1 by 2 is equal to 1 plus, that is 2 by 2 is equal to 1. So tossing the coin here independently is a Bernoulli trial. So when a fair dice we are taking here, the numbers 1, 2, 3, 4, in the dice is 6 numbers 1, 2, 3, 4, 5, 6. The churnum, a 5 is considered a success and it is indicated by A. And A power C standard, A power C we can take that the standard for getting the one number 1, 2, 3, 4, 5, 6. In this case of probability P is equal to 1 by 6. While the probability of failure, P 6 by 6, 1 by 6 is a success, 5 by 6 is a failure. So the dice is independently is a we can take that the Bernoulli trial here. So therefore we can take here when we are taking here when a dice we are taking the Bernoulli trial, the dice is directly independent as a Bernoulli trial. Suppose a URN consists of B block balls and R is red balls. Block balls we are taking B and R is balls is red balls. If ball is selected at random from the URN, then it can be the either block or red ball, block or red ball. It's selected, if block ball is selected, is put black into the URN, then each of the probability getting block P is equal to B by B plus R, and as well as the probability of getting red ball Q is equal to red block ball వచ్చినప్పుడు we are writing B by B plus R, red ball we are writing Q is equal to R by B plus R. B plus R is same, but we are changing B is equal to black ball and R is equal to red ball. We are changing the same. So when in a production process an item is produced, it may be considered a confirming when some quality characteristics within the specified limits or might be non-conforming item when the quality characteristics lies outside the specified limits. If we denote the event, an item is confirming one with A and A power C is non-confirming item here. So therefore, the probability of these events we are taking that. So what is the probability, or probability means event that with A and A power C. So the probabilities of these events, then it's called as a Bernoulli trial. Who is Ravi understanding? Okay. So definition of Bernoulli distribution. Anyone listening? Yes, anyone listening? Hello? I am audible? Invartunda? Hello? Okay. Definition of Bernoulli distribution. A discrete random variable x said to be a Bernoulli distribution if it assumes only two possible ways, 0 and 1, probability mass function. So probability mass function is PMF. So this assume two possible ways here, P of x is equal to x. So P of x is equal to x, what we are writing here? P of x is equal to P power x and Q power 1 minus this basic fundamental formula. This is x is equal to 0, 1, 0 less than P less than 1, P plus Q is equal to 1. These conditions we are taking here. So Px is equal to 0, the condition is 0 less than P less than 1 and P plus Q is equal to 9. I already told you P plus Q is equal to 1, Q is equal to 1 by 2 and Q is equal to 1 by 2, that is equal to 1. From the above definition, it is clear that Px is equal to 0. So therefore P of x is equal to 1 is equal to P we can take here. Properties of the Bernoulli distribution. So mean and variance. So mean Sagatu Vistruti, mean and variance. In x, if x is a Bernoulli variate, then its mean E of x is equal. So 0, 1 we are taking here 0 into Q plus 1 into P. So therefore 0 into Q is 0, 1 into P is equal to P we are taking here. So that is 0 into Q, that is 0, 1 into P is equal to P. X square variance 0 square, that is 1 square P is equal to P. So variance of x is equal to mu2. The condition formula is mu2 dash minus mu1 dash whole square. Formula mu2 formula is mu2 dash minus mu1 dash whole square. That is p minus mu2 dash is equal to p. P minus p square is equal to p. We are taking the common here. So that is p into 1 minus p. P into 1 minus p. 1 minus p means a q. So that is 1 minus p. P plus q is equal to 1. So therefore q is equal to 1 minus p. So therefore we can write here that is p into q. So that is p minus p square is equal to pq. We can write here. Mean greater than variance is characteristics. Mean greater than is variance for the characteristics of feature of the Bernoulli distribution we are taking here. Coefficient of skewness. What is coefficient of skewness? So we know that mu dash r. So mu dash r is equal to E x dash Mu dash is equal to E of x, E x minus E x dash. So therefore, mu 3 dash we are finding. Mu 3 means e power x3. We are taking mu 3 dash is equal to e power x3. So 0 power x3 into 1 cube. 1 is 0, 1 we are substituting here. So 1 cube or 1 power 4 also, it should be same. It is p, it came output. So mu3 formula generally we can take the mu3 formula, mu3 dash minus 3 mu2 dash into mu1 dash and 2 mu1 dash also. So mu3 dash is equal to, already we are finding the value of p. Then 3 into mu2 dash is equal to also p into p, mu2 dash mu1 dash, and that is mu1 dash whole cube is equal to also p cube. So that is p cube we are writing here. So therefore we are simplifying that p is a common, taking here this p into 1 minus p and 1 minus 2p. After the simplification we are writing the coefficient of skewness. So therefore coefficient of skewness is, therefore coefficient of skewness is b1 by mu3 square by mu2 cube. Mu3 square by mu2 cube, that when we can write here from the above condition, p square 1 minus p square 1 minus 2p square by p into, see here in the just a minute, p into 1 minus p whole cube. This one condition we are writing here. After the simplification, this one p is equal to 1 by 2 beta 1 is equal to 0. So this distribution x become is symmetric condition. The condition is following here. Moment generating function. If x follows Bernoulli distribution, its moment generating function is m of x is equal to e t x q into e power t0 p into e power t. Therefore, this condition p plus q we are taking the common here. E power t0, that is e power t here. E power t1 is e power t. So e power t is 0. So therefore we can write here q. Then e power t power 0 we can write here q. P into e power t we can write here. P into e power t we can write here. P into e power t we can take here. Then characteristics function. So characteristic function. What is a characteristic function? If x is a Bernoulli distribution of the characteristic function here, so phi of x, we can take here phi of x here. Phi of x is e into e power it. So what is phi of x? We are taking basic of e of x variance in the Bernoulli distribution. E of it x, we can write e of it 0 q plus e of it q. So we are taking that is a 0 function. We can write this is q, this is p into e of it. This is characteristic function of the Bernoulli distribution. So we can take the binomial distribution. Now we are taking here. Sheikh, you are listening? Sheikh, you are listening? Sheikh, Mr. Sheikh, you are listening? Okay. So binomial distribution we have to learn here. What is binomial distribution? The binomial distribution was proposed by, already I told you, binomial distribution proposed by James Bernoulli. It is an important theoretical distribution, wide application of social sciences, business and commerce also it should be using here. If you understanding, please reply.
Yes, sir.
Okay. Okay. Which study center you?
Hyderabad.
Okay. Okay. You are attended the practical classes at Hyderabad?
Yes, sir.
Okay. So, listen here. James Bernoulli, but it is an important theoretical distribution of wide the social science and business and commerce here. So, statistical quality control using construction control charts of fraction defective and the non-defective units P and NP charts we are taking here. Suppose what is the definition of binomial distribution? See here a discrete random variable. A random variable x is said to be follow binomial distribution with parameters n and p. It assumes only non-negative integer values and probability mass function. Probability mass function. So we are taking probability PMF is PMF. And then binomial distribution parameters we are taking n and p. So non-negative unnappudu px is equal to x we are taking here the condition of ncx p power x and q power minus x. So x is equal to what we are writing 0, 1, 2, 3 and so on n. So px is equal to 0, 0 less than p less than 1, and p plus q is equal to 1. So the condition we are taking is therefore q is equal to 1 minus b. Ravi, you are understanding? Mr. Ravi? Mr. Ravi, I am audible? Okay. So in production, one example we have to take here. In production process, these chance, the chance that an item defective is 5%. If a sample 10 items, is the taken probability the defect items can sample. See here, the total is 10cx. So what is the defective percentage? 5%. We can write 0.05% x. 1 minus 0.5 p plus q is equal to 1. So 1 minus 0.5, 0.95. So 10 we are taking it as 10 minus x. So there is no x given. So that's why only formula we are writing p of x is equal to 10 cx 0.05 whole power x and 0.95 q power x. What the formula is ncx into p power x q power n minus x. In formula the values I am submitted. Understood? Understood both of you?
Yes, sir.
Derivation of binomial distribution. Derivation of binomial distribution option. So consider sequence of n independent Bernoulli distributions. Trials of each, the probability success is p. Suppose our interest is in the trials. There are x success and n minus x failures here. Consider x success. Success means n minus x we are taking here. Failures of some specified order. Since the trials are the independent using the multiplication theorem of probability. So we are taking the get probability the above success p power x and q power n minus 1 we are taking here. By using addition the theorem, the probability we get the probability that there is x success in trials in any order ncx p power x q power n minus x. So what is the conditions here? The following experimental conditions are to be satisfied using a binomial distribution. Each trial results to exhaustive mutually exclusive outcomes generally termed as success S and failure F. The probability of success P is constant for each trial. The number of trials
Sir, there is some disturbance.
From your side, there is no disturbance with me. Now clear? Now clear?
Yes, sir.
The probability of success P is a constant of each trial. The number of trials in each failure and the number of the trials are independent. The trials are independent. The n is finite. The trials are independent. We are taking it. The most important topic: properties of binomial distribution. They will ask the properties of binomial distribution you have to take. The properties of binomial distribution. X has a binomial distribution parameters. N and P let us denote x equivalents b n comma p. So mean and variance x equivalents to b n comma b is the first moment origin. The first moment origin we can take here bx bar b n p. The first moment about origin is mu dash x is equal to e of x x power n x. So there's a fundamental formula is the same ncx p power x and q power n minus x. So I'm taking the np is constant here. So summation of I is equal to 1 to n, that is n minus 1. Taking that n minus 1, again I am taking the condition n minus 1 into n minus 1 minus 6, then p into x power minus 1, q into x power minus 1. I am taking that the mu dash expansion here. Then np is equal to the fundamental formula as per the simplification here. Np plus q plus p whole power minus 1. The condition, these condition np, q plus power minus 1 should be cancelled, is equal to np. So mean of the binomial distribution is np. The second moment origin, the second mu2 dash. So first we can find the mu2 here. So mu2 e power x square, the mu2 summation of x is equal to 0 and x square ncx p power x q power n minus x formula. summation of x is equal to 0, that this condition may be written as x into x minus 1 into x. Then again ncx p power x. The condition should not be changed here. Idi maatrame change avutundi, x into x minus x plus x. So after the simplification, this one may be simplification here, n into n minus 1 p square, and also summation of x power 2 to n minus this first condition is, see here, first condition is n minus 1 cx minus 1. This is n minus 2 x minus 2 p power x minus 2 q power n minus x. So plus np. So the condition is n into n minus 1 p square and plus np, the condition of the second moment origin here. The variance of this one mu 2 dash minus mu 1 dash whole square. This is a formula. Formula is n into n minus 1 plus p square plus np n square minus p square. So multiplying and cancelling here, n into n square minus 1 np square n square p square minus n square p square plus np minus n square p square. Should be cancelled some words, some np minus np square. So I'm taking that np is common here, 1 minus n. So 1 minus np is equal to 1, and 1 minus np is equal to q. 1 minus np is 1 plus p plus q is equal to 1. So therefore 1 minus p is equal to q. So therefore np is equal to npq. So variance of the binomial distribution is npq. So see here, mean greater than variance, the condition of the characteristic feature of the binomial distribution. So 0 less than p less than 1 and np greater than npq, this we are writing here. For a binomial distribution, for a binomial distribution, x equals to b n comma p for the third moment origin is, so third moment origin is mu 3 d dash mu 3 e dash ex cube is equal to summation of x equal to n, x is equal to 0 to n x cube is same formula ncx p power x q power n minus x. So therefore we are taking here, so the x cube is equal to a into, this is a into x minus 1 x minus 2. We are taking the partial fraction method here, a into x minus 1 and x minus 2 plus b into x minus 1 plus cx plus d. Why? Because x is x cube, this we are writing x cube here. So therefore x cube minus means a into x minus 1 x minus 2, square means x into x minus 1, then again constant cx1 x is there, another constant is here. So we can solving the from the left and right. We can left and right. We are taking here d is equal to 0. So we can solving in the same x is equal to 1 and c is equal to 1 and x is equal to 1. We can say here x is equal to 2. X is equal to, we can simplification of this one here. Here 8 from the left side we can take that 8 is equal to b plus c. Those automatically they may be b is equal to 3. So x cube is equal to 1. X cube is equal to 1 is equal to a. So mu 3 dash is equal to, we are writing a summation of x3, summation of I x is equal to 3 is equal to n x into x minus 1 x minus 2 plus 3 x into x minus 1 plus x power n. So we are writing c power x, q power x and q power n minus x. So what is the, because of the condition we are taking here x into x power minus 1 x power 2. So with the condition n power x and p power x and q power n minus x, the basic condition we are writing, and automatically, so we can take the condition here. This condition n into n minus 1 into n minus 2 p, summation of x is equal to 3 n minus 3 c x minus 3, the simplification of p x minus 3 q n minus x. The condition of the simplifying here into plus 3n into n minus 1 p square summation of x2 is equal to n minus 2 x minus 2 p power x minus 2 q power n minus x plus np summation of x is equal to 1 n minus 1 c x minus 1 p power x q power n minus x. Just a minute. So n into n minus 1 n minus 2 p cube, then 3 into n minus 1 p square np we are writing here. We know that the third central moment, you know that mu 3 is equal to mu 2 dash minus 3 mu 2 dash plus into mu 1 dash. So mu 3 dash minus 3 into 3 mu 2 dash plus 2 mu 1 dash whole cube. So therefore we are writing here npq is equal to 1 minus 2p. npq is equal to 1 minus 2p. We can write q minus p. So therefore coefficient of skewness of this one we are writing here mu 3 square by mu 2 square, mu 3 square by mu 2 square, that we are writing n square p square q square. The fundamental formula writing q minus p square by np cube. After simplification, this one under root of b1 is equal to 1 minus 2p by under root of np cube. So under root of b1 by under root of np cube. So beta 1 and gamma 1 do not depend on the value of x. When p is equal to 1 by 2, the distribution is symmetric. If p less than 1 by 2 is the distribution of is asymmetric, and gamma 1 is positive. P greater than 1 by 2 is asymmetric and gamma 1 is negative. అంటే less than కనుక ఉంటే it should be positive, and greater than కనుక ఉన్నట్టయితే it should be negative for the values of this one. Coefficient of excess of keratosis. So we can take here. So mu 4 dash x equivalents to b n comma p. The fourth central moment, the fourth moment of the origin is we can take the mu 4 dash e power x power 4. Summation of x is equal to 0 to n x power 4. Same formula n c x p power x and q power n minus x. So x power 4 already we can take the same partial fraction a into x minus 1 x minus 2 x minus 3 plus bx into x minus 1 x minus 2 and cx into x minus 1 plus dx plus c. అంటే x తీసుకుంటున్నాం, స్క్వేర్ తీసుకుంటున్నాం, క్యూబ్ తీసుకుంటాం, కాన్స్టెంట్ తీసుకుంటాం, ఈ తీసుకుంటున్నాం. సో దీస్ కండిషన్స్ e పవర్ 0 x1 is equal to d1 అవి లెఫ్ట్ సైడ్ లో కండిషన్స్ క్యాన్సిల్ చేస్తాం, మనకి రావాల్సిన వాల్యూస్ వస్తాయి. సో 1 is equal to a. Just a minute. Okay, so we are taking the from the left hand side, and partial fraction method we done. So the a is equal to 1, and we a into x minus x1 x minus 2 x3, and bx x minus 1 x minus 2 cx x minus 1 dx plus c. So d is equal to 1. So dx constant d x 1 ఉంది కాబట్టి dx is equal to, so therefore d is equal to 1. d value so x is equal to 2 substitute చేస్తున్నాం ప్రతి దగ్గర. So d is equal to 2 substitute చేస్తే d is equal to x is equal to 2 substitute చేస్తున్నాం, 2 is multiply చేస్తే 2c plus 2c plus 2d వచ్చింది. 2 కామన్ తీస్తే c plus d. d ఆల్రెడీ మనకు ఒకటి అని తెలుసు ఇక్కడ. సో d తెలుసు కాబట్టి 7. సో x is equal to 3 సబ్స్టిట్యూట్ చేస్తే 2b plus 2c plus d. సో c వాల్యూ d వాల్యూ సబ్ చేస్తే b వస్తుంది. సో x power 4 is equal to 1 is equal to a. x power 4 substitute చేస్తున్నాం. సో therefore mu 4 dash x is equal to 4 to n x into x minus 1 x minus 2 x minus 3 6 into x minus 1 ఇక్కడ సబ్స్టిట్యూట్ చేస్తున్నాం. ఏ ప్లేస్ లో వాల్యూ 1, b ప్లేస్ లో వాల్యూ 6, c ప్లేస్ లో వాల్యూ 7, d ప్లేస్ లో వాల్యూ 1. సబ్స్టిట్యూషన్ ఈ కాన్స్టెంట్ 0. సో సబ్స్టిట్యూట్ చేస్తే the value is ncq p power x q power minus x. So after the simplification here, n into n minus 1 n minus 2 n minus 3 p power 4. So after this simplification, we know that n into n minus 1 n minus 2 n minus 3 p power 4, 6n into n minus 1 n minus 2 p power cube, 7 into n minus 1 p square into np. So this is we know that the basic conditions here.
Okay, sir.
Mu power 4, mu power 4, the fourth central moment mu power 4, mu power 4 dash minus 4 mu 3 dash into mu 1 dash, 6 mu 2 dash 6 mu 2 dash mu 1 dash whole square 3 mu 1 dash whole 4. This is a basic fundamental formula. After this simplification, this formula it may become 3n square. This is the simplification of this one. It's maybe 3n square p square q square npq 1 minus 6 npq. So that is a gamma 2 is equal to beta power 4 minus 3, that is 1 minus 6 pq by npq. It is a simplification, that one. It is a simplification by b4 is equal to mu 4 by mu 2 square. That is 3n square p square q square plus npq 1 minus 6 pq by np square. We can simplify here. We can simplify. This is the 3 common I am taking here. This maybe we can treat it as n square p square q square. 1 should be cancelled here. 1 npq here. So therefore npq we can take that 1 minus 6 npq. So this is a basic fundamental of this one. This is the most important theorem you will ask in the coefficient of excess of keratosis. They will ask in the maybe asked in the exams. When the number of independence trials extends to infinity, So beta 1 tends to 0, beta 2 tends to 3. In the case of binomial distribution, tends to normal distribution. So moment generating function we have to learn. X is equivalent to b n comma p, then it's moment generating function we have to take mx of t. So mx of t we are taking that e power of eitx, e power of itx. So summation of x is equal to 0 n. So e power tx, e power itx, ncx, p power x and p power q power n minus. Summation of x is equal to 0. So therefore n power cx, this we are writing here p e power tx, we are writing this p e power tx, we are writing q power n minus x. So this may be simplification formula is p plus q e t is equal to whole power n. This is the basic fundamental formula of moment generating function here. So we know that here mu dash r we are taking here. So d by d square by dt power r, d square by dt power r mxt is equal to r is equal to 1. From 1, 2, 3, 4 we get here. The basic fundamental formulas we have here. Mu1 dash is equal to np. Basic fundamental formula is most useful this one. Mu1 dash is equal to np. Mu2 dash is equal to mu2 dash is equal to n into n minus p square plus np. Mu3 dash is equal to n into n minus 1 n minus 2 cube plus 3 into n minus 1 3 n into n minus 1 plus p square np. Mu4 dash into n minus 1 n minus 2 n minus 3 p power 4 6 n minus 1 n minus 2 p cube 7 n minus 1 p square plus n. We are obtaining the central moment using the moments about the origin we are taking here. These are the most important formulas we can use here.
Okay, sir.
Then characteristics function. They will ask in the examination process also, write the properties, write the characteristic function in the short question. So if excellence b, if x equivalents to b and n beta is a characteristic function, already we learned here. So pi of t of is equal to eitx, summation of x is equal to eitx ncx, p power qx. So ncx and already itx I am taking here this one, p of e power itx q power n minus x. So the condition is p into q plus p. We are writing this condition is q plus p e power it whole power n. Why? Because already I told you this one. This one I already told you, q plus p e power tin. The same has been done here, ncx p power itx q power n minus x. This is a condition. So q plus p e power it whole power n. This is a condition for characteristics of function of probability generating function. If excellent b n comma p, then its probability generating function is p of s is equal to is equal to s power x. Summation of x is equal to 0 to n sx ncx p power x q power minus x. The same condition of p power x and q power minus x. So summation of x is equal to 0 n ncx p power s whole power x q power n minus x. So this is also p. Same condition ncx p power x means this is q, this is q, this is p plus s, this is this. Oh, just a minute. This is q, this is q, this is ps, this is whole power n. The condition is satisfied here only. Additive property of the binomial distribution. Suppose x and y are two independent random variables. Independent random variables. Suppose both are independent, not dependent x and y and y and x. So equivalence to b n1p, y equivalence to b n2p. Since x and y are independent, that is equal to x plus y. We know that phi to t is equal to phi of x plus z of phi, phi z of t is equal to phi x plus y. That is equal to x plus y we are taking here. Phi is equal to zx plus t. We are taking phi of x of t and phi of y of t. Multiplication process we are doing here. I am separating phi of x and phi of y. So in phi of x we are writing here p q plus p e power I t whole power n1. That is phi of x. And second one is q of phi of x q plus p e power e t n2. So that is both the bases are same. Both the bases are same. Q plus p into I power t whole power n plus n1 plus n2. Both the bases are same. So therefore, the uniqueness of the property characteristic functions here. So z is equal to x plus y is the binomial distribution of parameters n1 plus n2 and p. In general, x equal in general here. In general, of x equivalents to b n I p I is equal to 1, 2, 3, and so on, k are independent, then we can write here x1 plus x2 plus x3 plus and so on xk as a binomial distribution. We are binomial distribution with parameters n1 plus n2 plus n3 plus n4 and so on nk and the parameter. Binomial distribution x vaడుతున్నాం and parameters with parameters n vaడుతున్నాం మనం here. The difference between the independent and two independent binomial variates is not a binomial. The independent binomial variates is normal, not a binomial variate. ఇండిపెండెంట్ బైనామినల్ వేరియట్ కంపల్సరీగా బైనామినల్ వేరియట్ కావాల్సిన పని లేదు, ఎందుకంటే దాని వాల్యూస్ దీని వాల్యూస్ సేమ్ ఉండకపోవచ్చు కూడా. ఇఫ్ ఎక్సలెన్స్ టు బి n comma p, then y n minus 6 is the binomial distribution with parameters of n and q. Very most important cumulative generating function, optional. So see here with x equivalence to b n comma p, then its cumulative generating function is kx comma t. We can write here log mxt is equal to log mxt means we are writing q plus et. This is a base q plus pet whole power n is as usually we are writing here. So n log p plus qut n log, so n log p plus q. What is e power t? E power t means we are writing here 1 plus t by 1 factorial, t square by 2 factorial, t cube by 3 factorial, t power by 4 factorial, e power t. So I'm taking n log here, automatically p plus p. Then I'm q plus p I'm taking here, then p, so 1 plus, so we are taking p is a p into 1, p I'm taking common here again, so multiplying 1 into t, so p into, so 1 into t square by 2 factorial, t cube by 3 factorial. N log is equal q plus p is equal to 1. Already I told that p plus q is equal to 1, we are writing here, then p into t plus t square by 2 factorial, t cube by 3 factorial we can write here. And again n into p into t again this is expansion of log, we are expanding here, n into p of bracket start 1 into t square by 2 factorial plus t cube by 3 factorial, so on, minus second condition minus p square by 2 t plus t square by 2 factorial plus p cube by 3 t by t plus t square by 2 factorial, another one. And the even numbers are negative, odd numbers are positive. Clear? Shay, clear?
Okay, sir. Yes.
The even numbers are negative and odd numbers are positive here. So therefore k1 is coefficient of kx power t is equal to np, mu to coefficient of t square by 2 factorial kt is equal to npq, and the k3 coefficient of t cube by 3 is equal to np 1 minus 3p plus 2p, which is implication of npq 1 minus 2p. Coefficient of t power 4 by 4 factorial k power 4 by k power 4 by t, that is 3n square p square q square npq 1 minus 6pq. Last you have to note it. All these formulas, no, you did not note it. Last one k1 np, k2 npq, k3 npq 1 minus 2p, k power 4 3 square n square p square q square plus npq 1 minus 6 npq. You have to note it. Mode of binomial distribution we have to do here. So p of x p by p of x minus n cx p power x q power n minus x, n cx minus 1 p power x minus 1 q power n minus x plus 1. So see here we are doing here, so n cx p power x q power minus x. So this condition may be written as here n minus x plus 1. This condition may be written as n minus x plus 1, and this is in the Newton in the denominator part, that is x into p into p. So we are just simplifying that n minus x plus 1, that is n plus 1 into p minus xp by x cube. So 1 by, so we are taking the 1, we are taking the common here. 1 by 1 and plus 1 into p minus xb by x cube, plus 1 I'm adding plus 1 and minus 1 adding here. Plus
Sir,
1
how we got x into q?
Where q? This one.
In second step, yes. Yes,
This
sir.
one. Yes, this one. This one.
Second one.
This one.
Uh,
Huh? See,
no, sir, upper one, yes, this one. In denominator, we got x into q, so how we got that?
this p.
Yes, sir.
This p you are asking?
No, sir, in denominator, x into q is there, na?
Yeah,
Yes,
yeah,
this one.
yeah. This NCX, 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 x minus 1, this one, p into x power minus 1 to q into x power minus 1. The value substituting, the value after the value substituting is a q power 1. After the value substituting in the b power np, it 1. So therefore we are writing q here. P is 0. See here. This is 1 minus p is 0, 1 minus 1. This is also we can take here. So the value is 0. The remaining value is only q here.
Okay.
Then again one by we are 1 plus 1 adding and minus 1 adding here, and plus 1 minus 1 adding here, the same about the formula. So 1 plus n plus 1 into x minus p, taking the LCM here for this one, taking the LCM n plus 1 mu minus p into x cube by x cube. So therefore simplification px by x minus 1 1 plus n plus 1 b minus x by x cube. ఎందుకు చేస్తున్నామంటే ప్లస్ 1 మైనస్ తో చేస్తే మనకు కావాల్సినటువంటి x క్యూ వాల్యూ కిందనే ఉంటుంది, x వాల్యూ మీదికి పోవడానికి మనం ప్లస్ 1 మైనస్ 1 యాడ్ చేస్తున్నాం ఇక్కడ. So now we will following the two cases here. So therefore case 1, if n plus 1 is n plus 1 p is integer, it says p1 by p0 greater than 1, p2 by p1 greater than 1, p3 by p2 greater than 1, and lastly pm by pm minus 1 greater than 1. So అది కానీ m లో ఉన్నట్లయితే m లో కండిషన్ లో అయితే pm plus 1 by m less than 1, pm plus 2 by m less than 2, and so on pn by n minus 1 less than 1. The condition is satisfied. p0 less than p1 less than p2, p0 less than p1 less than p2 less than, and so pm minus 1 less than pm. అంటే ఈ 0 నుంచి m వరకు లెస్ దాన్ అవుతుంది, m plus 1 నుంచి greater than అవుతుంది. So well, greater than pm less 1, greater than pm plus 2, and so on greater than pn. So in this case distribution, binomial having modes x is equal to m minus 1 and x is equal to m we are taking here. So therefore it's most important you have to practice it, check. So p1 by p0 greater than 1, p1 by p2 greater than 1, pm by pm minus 1 already told. So pm by pm plus 1 by pm less than 1, pm plus 2 by pm plus 1 less than 1, it is less than 1. The condition is already p0 less than p1 less than p2, and so on pm minus 1 less than pm less pn. Already I told that again. So in this case the distribution is unimodal x is equal to m. అంటే లెస్ దాన్ ఉన్నప్పుడు 0 నుంచి m దాకా లెస్ దాన్ ఉంటుంది, m plus 1 నుంచి గ్రేటర్ దాన్ ఉంటుంది. ఇది యూనిమోడల్ అవుతుంది కాబట్టి ఇది x is equal to m గా రాసుకుంటాం. అదేవిధంగా రికరెన్స్ రిలేషన్ ఫర్ బైనామినల్ డిస్ట్రిబ్యూషన్. If x belongs to b np, then p of x is equal to ncx p power x q power n minus x. So therefore we are writing here p power x plus 1. So therefore n into cx plus 1 p power x plus 1 q power n minus x minus 1. As per the above formula, we are x plus 1 adding here. So therefore adding here the same here p power x plus 1, adding 1. So this is the same here p power x plus 1 by p power x. So this is the condition is ncx is this is the one n minus x, and this is after the simplification n minus x is x plus 1. So p power x plus 1 by q power x minus 1.
So sir, why there is no q to the power x plus 1?
Yes, I will again explain you. Just wait. So p power x plus 1, p into x plus 1, that is I am division p into cx plus 1, nc into ncx plus 1, p power x plus 1, q into n minus x plus 1. Now understood this one? If both the conditions I am writing x and x plus 1. Listen here, p power x is ncx and p power x q power minus 1. Okay? Check. Hello? I am audible?
Yes sir, yes sir.
ఇప్పుడు p power x plus 1 అంటే ఇక్కడ ఏం రాస్తామమ్మా? ncx power plus 1, p power x plus 1, q power n minus x minus 1. Correct?
Yes sir.
What is p of x? ncx p power x q power n minus 1x. Correct?
Yes sir.
ncx లో నుంచి అంటే ఇప్పుడు ఏమని రాసుకోవచ్చు ఇది నువ్వు? ncn plus ఎన్సి ఎన్ ప్లస్ వన్ అవునా?
Yes, sir.
ఎన్ ప్లస్ వన్ క్యాన్సిల్ అయిపోతాయి ఇక్కడ. ఇప్పుడు ఇప్పుడు సింప్లిఫికేషన్ చేస్తే ఎన్సిఎక్స్ సింప్లిఫై చేసి రాస్తాం. ఎన్ ఇంటూ ఎన్ మైనస్ వన్ ఎన్ మైనస్ టూ అండ్ సో ఆన్ ఎక్స్ అని రాస్తాం అవునా?
Yes, sir.
ఇప్పుడు ఎన్సి ప్లస్ వన్ అంటే ఏం రాస్తావు? ఎన్ ఇంటూ ఎన్ ప్లస్ వన్ ఎన్ ప్లస్ టూ ఎన్ ప్లస్ త్రీ అండ్ సో ఆన్ అని రాస్తామా? ఆ మీద కింద క్యాన్సిల్ అయిపోయిన తర్వాత నీకు ఎన్ మైనస్ ఎక్స్ న్యూమరేటర్ మిగిలిపోతుంది. ఎందుకు మిగిలిపోతుంది? ఎక్స్ ప్లస్ వన్ కదా ఇది.
Yes, sir.
ఎక్స్ ప్లస్ వన్ కాబట్టి మీద ఎన్ మైనస్ వన్ ఎక్స్ ప్లస్ ఎన్ మైనస్ ఎక్స్ మిగులుతుంది. కింద ఏం మిగులుతుంది? ఎక్స్ ప్లస్ వన్ ఎందుకు మిగులుతుంది? అప్ టు ద కండిషన్ ఎక్స్ ప్లస్ ఎంత కండిషన్ ఇది మీద క్యాన్సిల్ కాదు కాబట్టి కింద ఎక్స్ ప్లస్ వన్ మిగులుతుంది అవునా?
Oh, yes, sir.
అప్పుడు ఆటోమేటిక్గా ఇది పీ పవర్ క్యూ ప్లస్ వన్ క్యూ పవర్ మైనస్ ఎక్స్ వన్ వాల్యూస్ 0 అయిపోతాయి కాబట్టి దట్ ఈస్ పీ బై క్యూ.
Okay, sir.
సో p power x plus 1 minus x by x power plus 1 p by q power x. So p power 0 is equal to q power n. Then cumulative distribution function. The cumulative distribution function we are taking here. When x power x equivalent to b n comma, the cumulative distribution function is capital X less than or equal to x. Summation of r is equal to 0 to x ncr p power r q power n minus r, the basic condition. So ncx n minus x is integration of 0 to q. This is the basic fundamental formula. Integration of 0 to q y power n minus x minus 1 1 minus 5 into x power dy. This is a condition you have to learn here. Then recurrence relation central moments. This is, you may be ignore it. Don't worry. Recurrence relation cumulation. This is the practicals. So in x equivalent to b n comma p, log to cumulant is k power r, d power r by dtr log mx t is equal to 0. So d power r by dtr log mx t, you know that log mx t is equal to q in q plus p power t, t0. Log q plus n is common here. So why we are taken here, tell me? Why we are taken?
Common.
Where just a minute. D by d power r by dt power log eq. Here n is there. See here.
Yes, sir.
Correct?
Yes, sir.
D power r by dt power log q plus at. So partial derivation d power n, d power r by d power r, again partial derivation, that is d by dp with respect to r log, అంటే దీన్ని d power r తో చేస్తే ఏమవుతున్నాం, అంటే this is x and d by dp like 0. Just a minute. So n into d power r by d power r. So d power r. So log, we are removing the log here. The differentiation d by dp of log differentiation d by dx of x 1 by x. Avunga? Correct?
Yes, sir.
So 1 by p plus e power t. Again we are differentiating 1 plus e power minus t. So d by dx of 1, that is minus 1, and the p is a constant, that is e power t. Correct?
Yes, sir.
So therefore k r plus 1 d power r plus 1 by d power r plus 1. Again the plus 1 we are taking here, plus 1 I am adding here. Add 1 log of d plus et, and n we are taking here d power r by log e plus t. So n into d power r by d power r, again 1 by q plus et. So that is the basic fundamental. So p is the constant, only single number is there, that is 0. So p et is there, that is x. So directly write p into e power t. That is the condition what we have written here. So n into d power r, n into d power r by dt power r. So q plus, I am simplifying the equation here. I am taking the LCM here. So q plus p power et into minus q. Q plus e power t by q plus e power t minus t. Simplification to 1. We are taking that 1. We are taking the 1 q plus e power t. 1 we are taking here. So the 1 into q plus e power t minus q by q plus e power t. So q plus e power t, I am taking the LCM. Q plus e power t into 1 q power e power t 1 minus q q. So automatically the value should be the same here. So minus nq. What is q? Where we q ఎక్కడి నుంచి తీసుకొచ్చాం? ఇక్కడ తీసుకొచ్చాం. minus nq d power r by d power r 1 by 1 plus q into e power et t. Clear?
Yes, sir.
Therefore, kr plus 1 minus q, kr plus 1 dp by dp by dp by d by dp kr is equal. This is a major differentiation. Minus nq d power r by dt r 1 plus 1 by q plus p power et minus npq. Here minus చేసాం కాబట్టి minus npq d by dpr 1 power e minus t. So simplification minus nq d power r by dtr. ఇక్కడ ఈ minus nq ను నేను కామన్ తీస్తున్నాను. సో therefore ఇది కూడా తీస్తున్నాను d power r 1 చూడు 1 minus p 1 minus p 1 minus et by q plus et. Correct?
Yes, sir.
Is equal to 0 minus n to d power r by dt power r. Simplification, I am taking the simplification one. 1 plus minus into minus plus p e power t, then minus p by q plus e power t. Minus n to d power r by d power r. Q, just wait. One plus p, what is the value? P plus q is equal to how much? 1. Ona? P plus q is equal to how much? 1 na? Hello? Okay. Replace it. P plus q is equal to 1. Therefore, 1 minus p is equal to q. So q 1 minus q is equal to the right q plus pet by q plus pt cancel here. So we are supplying is 0. So it is applying is 0. So the k plus r1 pq dp by dr kr is equal to 0. The condition is satisfied here. So therefore k is equal to mean np we are writing here. Therefore k2 is equal to condition. K2 is equal to writing here condition here. pq by 1 dp by dp by np constant here, d by dp p dp by n constant. So p is there, pq, so p is a constant, dp by p అంటే ఎంత 1 కదా, dp by p correct. See, dp by p1. So dp by n, p into 1 into n, therefore pq into n. So k3 pq P3 PQ into d by dp nq. So therefore, again we are taking the n constant here, npq, d by dp of pq. So it is a derivation one. P లో చేసినట్టయితే UV method లో చేసినట్టయితే q minus p. So therefore, K4 pq by d by dp. So npq minus q, npq pq minus p. So therefore, the condition npq d by dp of p, this p I am taking the common here. P I am taking the common 1 minus np 1 minus 2p. Observe this is the multiplication. 1 into 1 1 1 minus 2p minus p 3p 2p into p 2p square. So npq is equal, this is a fundamental 1 minus after derivation I am doing here. See here, derivation I am doing here. Any doubt? No. Okay. Yeah. So 1 minus see here, just a wait. Derivation d constant is 0, d by dp of p అంటే 1 అండి, d by dp of p into 1, p అంటే 1, d by dp of 3p p 3p స్క్వేర్ ఇక్కడ ఇది p స్క్వేర్ అవుతుంది, 3p into p 3p స్క్వేర్ అంటే 6p డెరివేషన్. ఇక్కడ 2p క్యూబ్ అంటే 2p క్యూబ్ అంటే 6 ఆర్ 3 2 6 6p స్క్వేర్. ఆఫ్టర్ ద డెరివేషన్ ఇది ఇక్కడ ఏం చేయలేదు నేను, p మైనస్ 3p square plus 2p cube. Clear? So దీని డెరివేట్ చేస్తున్నాం dp by p1 అంటే 6p. ఇది 3 into 2 6p square. So 1 by 6p కామన్ తీస్తే 1 minus p. So 1 minus p అంటే p plus q is equal to 1 కాబట్టి np is equal to 1 minus 6p cube. This is the basic condition of this is a basic condition of this one. So we learned in this unit trial the results. Two and only mutually exclusive and exhaustive success failure with constant probability such trials as called as Bernoulli. A discrete random variable takes only two possible values, constant probability called as Bernoulli value. Bernoulli distribution probability success is mean, variance is PQ. Mean greater than variance is characteristics of the Bernoulli distribution. James Bernoulli proposed as Bernoulli distribution. Bernoulli experiment is repeated independent for a times of the number of successes observed in those as a binomial distribution. Binomial distribution, there are two parameters, that is NNP. Mean binomial distribution NP and variance is NPQ. Binomial distribution formula B1 is equal to Q minus P square by NPQ. To B2 that is 3 plus 1 minus 6PQ by NQ. Q is the distribution is symmetric. As the number of independent trials become identifiably large, the binomial distribution approaches the normal distribution. A positive integer binomial distribution x is equal to m1, m minus 1 and x is equal to m. M is the integer and the binomial distribution x is equal to m. Sum of independent binomial values with the same probability success and failure is also binomial value. Already I told here phi of x is equal to q plus p into e power I t whole power n. Moment generating function m of x is equal to p of plus q power t whole power n. There is no change in the characteristics of binomial and generating function 2 plus p power e power whole power n. Probability generating function also q plus p power e power t in place of s. We are writing this one. So this is the basic formulas in this first unit. Are you అర్థమైందా?
Yes, sir.
సో నెక్స్ట్ ఏంటి ప్రాబ్లం, ఎందుకు జాయిన్ కాలేదు?
Who, sir?
Another students are why joined, not joined?
At the same time, we have two classes, sir.
What classes?
Statistics and computer applications.
So a lot of people went into computer science.
Maybe, I thought.
So I will ask and change the timing. Okay.
Okay, sir.
Thank you. We will meet on 21st Sunday.
Okay, sir.
14th is I think holiday for Sankranti. If any class is there, I will post in the group.
Okay, sir.
Thank you.
Thank you, sir.